In this video, we will do some triangle congruence proofs where there are parallel segments involved. But let's warm up with these first four problems where we have parallel segments and we have to identify which pair of angles must be congruent. Looking at problem number 1, trace the sides that are parallel. These little arrows mean that these two sides are parallel. If you draw the transversal, it makes a letter Z or a sideways N. The corners of the N are alternate interior angles, so they will be congruent. Let's do problem number 2. Here are the parallel segments. Go ahead and draw that transversal. So the corners of the N or the Z are alternate interior angles. These will be congruent. So problem number 3 is very similar. Go ahead and trace the parallel segments. But this time, the transversal is across the back. Can you see a sideways, backwards letter F if you use your imagination? The corners of the F are corresponding angles, and corresponding angles will be congruent. And something similar happens on problem number 4. Here are the parallel lines. Okay, these are parallel. Here's the transversal that goes across the back. Again, you can kind of see a sideways letter F. The corners of the F are corresponding angles which are congruent. Let's go ahead and do an actual proof. Problem number 5. Let's start with the given. Segment BC is congruent to segment DE. So segment BC is congruent to segment DE. So of course the reason is given. So that's a congruent statement, so that's done. But there's another given right here. Segment BC is parallel to segment DE. That is also given. When you are given something that is not a congruence statement, you want to try to turn it into a congruent statement. So we're going to do something very much like what we did in the first 4 problems. Go ahead and trace the parallel segments. So here is BC, and here is DE. They are not only congruent, but they are parallel. We have a transversal going across the top. This creates a letter F that is sort of facing down. The corners of the F are corresponding angles, so they will be congruent. So we can go ahead and say that these two angles are congruent. For this first one, you have to use the 3-letter name because there is more than one angle here. So you have to call this angle A, B, C. That's the angle right here. And that is congruent to angle. Now, for the angle that's here at D, you could use the 3-letter name like angle BDE. However, because it is the only angle at letter D, you could simply call it angle D. So the reason why we knew those angles would be congruent is because they are corresponding angles. So that's why the reason will be the corresponding angles theorem. All right, it's the corresponding angles theorem. So when you see the letter F shape, that's when it's corresponding angles. When you see a letter Z or a letter N, that's alternate interior angles. Anyway, let's move on. There's one more given. Erase these marks real quick. So here's one more given. B is the midpoint of AD. So AD is right here. If B is the midpoint, that means that AB is congruent to BD. So we can, well, first we have to write down the statement. Okay, B is the midpoint of segment AD. So that was just the given. But notice how we were able to mark these two segments congruent. That's how we turn this statement about a midpoint into a congruence statement. So we can go ahead and say that segment AB is congruent to segment BD. For the reason, we simply put the definition of midpoint. When you are looking for the reason that goes right here, a hint about what it should be will probably be in the previous statement right here. So notice that the previous statement is about a midpoint. So that's a hint that the reason will be definition of midpoint. Now we are ready to say that the two triangles are congruent. So we can go ahead and say that triangle ABC is congruent to triangle BDE. And the reason will be something like side, 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 or side, angle, side. In this case, it's going to be side, angle, side. If you look at one triangle at a time, like consider this yellow triangle right here, you notice that we have two sides and an angle. So that means this would be either side, side, angle, or it will be side, angle, side. Well, we learned that side, side, angle doesn't actually prove triangles are congruent. So it really had to be side, angle, side. Also, side, angle, side means that the angle is between the two sides. And we see that this angle is in fact between the two sides. So that's it for problem number 5. Problem number 6. Let's start with the given. Angle A and angle D are right angles. So angle A, I need more space. Let me write a little smaller. Angle A and angle D are right angles. That is given. This is not a congruent statement, so I want to turn it into a congruent statement if I can. It actually turns out to be super easy. If A and D are right angles, then A is congruent to angle D. And the reason is that right angles are congruent. Again, if you want to know a reason that goes here, look at the previous statement here. It mentions right angles, and then the reason is right angles are congruent. Time to move on to the given. So we did that first one. Now we have AC is parallel to BD. Let's write that down. Oh wait, let's mark this. A and D are right angles, so we should put that in the picture. A and D. Now, segment AC is parallel to segment BD. That's given. We need to turn that into a congruence statement. Let's trace these. AC is right here, and then BD is right here. So these are parallel. If you draw the transversal, it forms a letter Z. The corners of the Z are going to be congruent. These are alternate interior angles. So first of all, look at the two angles that I just marked. That's going to be the congruent statement that goes next. you have to use the three-letter name. For example, angle ACB is congruent to angle DBC. The reason is that these are alternate interior angles. So we are going to put alternate interior angle theorem. All right, if it forms a letter Z, it's the whoops, I forgot the E. It's the alternate interior angles theorem. If it forms an F, then it's corresponding angles theorem. Okay, we've used up the given now. We need something else. We don't have enough quite yet. Is there anything we can mark automatically? We can mark the shared side. That will be automatically congruent. And the shared side is segment CB. So we write segment CB is congruent to segment CB. When you write this silly statement where you have something congruent to itself, that is called the reflexive property. The reflexive property. Now we have enough information to prove the triangles are congruent. So we can go ahead and say triangle ABC is congruent to triangle DCB. The reason will be something like side, 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 side angle, side, something like that. Look at one triangle at a time. I'm noticing this is a right triangle, so I should first ask myself, is this hypotenuse leg? I see that the hypotenuse is marked, all right? That's the double mark right there is the hypotenuse. But what about a leg? A leg would be any other side. No other sides are marked. So we have a hypotenuse but no leg. So this is not hypotenuse leg. Viewing this as a regular triangle, I see that we have two angles and a side. So it's either angle, angle, side, or it could be angle, side, angle, which also involves two angles and side. It will be angle, side, angle only if the side is between the two angles. If the side is not between the two angles, that's when it is angle, angle, side. Well, looking at the yellow triangle only, here are the two angles that are marked. This is the side that is between those two angles, but the marked side is something else. So the marked side is not between the two angles. That makes this angle, angle, side. So that's it for number 6. Look at problem number 7. Let's start off with the given. The first given right here says segment AC is parallel to segment BD. The reason is given. We need to immediately turn this into something is congruent to something. The way you turn parallel into a congruence is go ahead and trace those parallel segments. So there's one and there's one. And then make the transversal. So we see a letter F, sort of a backwards and sideways letter F. The corners of the F will be congruent. So that's angle A, which is congruent to angle. So this next angle, I have to use the 3-letter name. For example, angle DBE. Now, what about the reason? The corners of an F are corresponding angles. So we will write the corresponding angles theorem. What else is in the given? Well, we have this. B is the midpoint of segment AE. So that is given. That's a very nice sentence, but we need to turn that into a congruence statement right away. If B is the midpoint of segment AE, that means that AB is congruent to BE. So let's write that down. Segment AB is congruent to segment BE. What will the reason be? If you want to know the reason that goes here, oftentimes you will find a hint if you look in the previous statement. The key word here is midpoint. That's why the reason will be definition of midpoint. Is there anything else in the given? We have one more given right here. And this is an actual congruent statement. Angle C is just straight up congruent to angle D. So that is another given. And we should mark that. So angle C is congruent to angle D. That's actually enough information to prove that the triangles are congruent. So we can go ahead and say that triangle ABC is congruent to triangle BED. All right, the last statement is always going to be whatever you were trying to prove. What is the reason? Is it side, 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 or what? Looking at one triangle at a time, look at this yellow triangle. I see that we have two angles and a side. So this is either angle, angle, side, or it will be angle, side, angle. It will only be angle, side, angle if the side is between the two angles. Well, looking at the yellow triangle, these are the two marked angles. This is the side that's between them. The marked side is somewhere else. So because the side is not between the two angles, that makes this angle, angle, side. So that's it for number 7. Take a look at number 8. Let's start with the given. Segment BC bisects angle DCA. Just write that down. Segment BC bisects, I can squeeze this in here, angle DCA. So that is simply given. We want to immediately turn this into a congruence statement. So how do I do that? Well, focus on the DCA part. That tells you which part of the figure to look at. DCA is this angle right here. Bisect means cut in half. So that means this angle is going to be cut into two smaller congruent angles. So these are the angles that we will name next. You must use the 3-letter name. For example, angle DCB is congruent to angle ACB. What's the reason? When you want the reason that goes here, you can often find a clue in the previous statement, right here. Notice that the key word is bisect. So this is going to be definition of bisector. But actually, there are two different kinds of bisector. There are angle bisectors and there are segment bisectors. Clearly, this is an angle that is being split in half. So we will call it definition of angle bisector. Okay, we have our congruent statement. Is there anything else in the given? Well, we also have this, a straight up congruence statement. We love those. Segment DC is congruent to segment AC, and that's just plain given. Let's mark it. Segment DC is congruent to segment AC. So we've used up the given. We only have 2 pieces of information. We need 3. Is there anything we can mark automatically? The shared side. Boom! That's going to be congruent for both triangles automatically. So the way we record that as a statement is segment BC, the shared side is segment BC, is congruent to segment BC. It's congruent to itself. Whenever you have something congruent to itself, you are talking about the reflexive property. Okay, we actually have enough information now to prove that the triangles are congruent. We have 3 pieces of information. So we can go ahead and say triangle BDC is congruent to triangle BAC. The reason will be something like side, 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 or angle, side, angle. I find it helps to look at one triangle at a time. So looking at the yellow triangle, I see that we have 2 sides and an angle. That would either make this side, side angle or side angle, side. Side, side angle doesn't actually prove that triangles are congruent. So this is a proof. So we have to use only ones that would work. So it's definitely going to end up being side angle, side. But let's look back. Remember that side angle, side happens when the angle is between the 2 sides. And notice that this angle is in fact between the 2 sides. So it does make sense. Oh, it looks like that was the last one.